Hello, I'm Anabel Renteria and I'm a PhD student in mechanical engineering. I'll be introducing Leonhard Euler's biography and mathematical contributions to science, which are still applied nowadays in different fields, including mechanical engineering. Leonhard Euler was born on April 15 in 1707 in Basel, Switzerland. He died on September 18 in 1783 in St. Petersburg, Russia. His father was Paul Euler and his mother was Margaret Brugger. He was married to Katharina Giesel. Leonhard Euler was born in Basel, but their family moved to Riehen when he was 1 year old. His father taught him some elementary mathematics when he was a kid. Later, Leonhard moved with his grandmother and attended school in Basel. However, it was a poor school in which mathematics was not taught. However, Leonhard had a lot of interest in mathematics by then that he started reading mathematics texts on his own. He entered to the University of Basel in 1720 at the age of 14 to obtain a general education before going to more advanced studies. Johann Bernoulli gave private lessons to him, and in 1723 Euler completed his master's degree of philosophy, comparing and constraining philosophical ideas of Descartes and Newton. He began studying theology in 1723 and as his father wished, but he switched to mathematics thanks to Johann Bernoulli that pursued his father, as they were friends during their undergrad days. Euler completed his studies in 1726 at the University of Basel, but by that time, Euler had already a paper print and a short article. Euler was offered an academic appointment for teaching mathematics in Russia. During his work in Russia, he lived with Daniel Bernoulli. Daniel Bernoulli was the senior chair in mathematics at the academy at the time. When Bernoulli returned to Basel in 1733, Euler was appointed with his position as senior chair of mathematics. Euler got married in 1734 with Katharine Giesel. They have 13 children, but only 5 survived their infancy. In 1736, he published his book Mechanica, which presented Newtonian dynamics in the form of mathematical analysis for the first time. By 1735, Euler's health problems began when he had a severe fever and almost lost his life. In 1738, Euler's eyesight problems began due to his cartographic work and lost an eyesight in 1740. However, it didn't stop Euler's research. Euler also won the grand prize of the Paris Academy in 1738 and 1740. By 1741, he decided to move to Berlin Academy, where he worked as a director of mathematics. During the 25 years he spent in Berlin, Euler wrote around 380 articles. He wrote books on the calculus of variations, on the calculation of planetary orbits, on artillery and ballistics, on shipbuilding and navigation, on the motion of the moon, and lectures on differential calculus. He also published a popular scientific publication called Letters to a Princess of Germany. In 1759, Euler assumed the leadership of Berlin Academy. In 1766, Euler returned to St. Petersburg, and as soon after his return to Russia, Euler became almost entirely blind after an illness. Because of his remarkable memory, he was able to continue with his work on optics, algebra, and lunar motion. After his return to St. Petersburg, Euler was 59 years old, and it was when he produced almost half his total works despite the total blindness. He was helped by his sons, Johann Euler and Christoph Euler, also by 2 other members of the Academy, Kraft and Lexell, and the young mathematician Fass, who became his assistants in 1776. Fuss helped Euler to prepare over 250 articles for publication over a period of about 7 years, in which he acted as Euler's assistant. After Euler's death in 1783, the St. Petersburg Academy continued to publish Euler's unpublished work for nearly 50 more years. He has 56 publications in total, where 550 were published before his death. Euler's work includes contributions in the area of mathematics, trigonometry, cartography, and others. Some of his most important contributions are in mathematical notation. Euler introduced several of the mathematical notation that is used today, such as the notation f of x in 1734 to describe a function and the modern notation for the trigonometric functions. He was the first to use the letter e for the base of the natural logarithm in 1727. Now is also known as the Euler's number. The use of the Greek letter pi to denote the ratio of a circle's circumference to its diameter, although it did not originate with him. He is also credited for inventing the notation I to denote the square rule of -1 in 1777. He also introduced the symbol for summation in 1755, and a lot of other different notations. Euler also contributed to complex analysis. He was the first to consider sine and cosine as functions rather than as a chord, as Ptolemy had done. Euler made ideas of Johann Bernoulli more precise in defining a function, and he stated that mathematical analysis was the study of functions. His work bases the calculus on the theory of elementary functions rather than on geometric curves, as had been done previously at that time. Another popular contribution is Euler's formula, which is applied in mathematics, physics, and engineering. Euler contributed to advanced analysis. He used and developed power series and expressed them as functions. He also found a way to calculate integrals with complex limits, foreshadowing the development of complex analysis. Euler invented the calculus of variations, including its most well-known result, the Euler-Lagrange equation. Euler also introduced the polyhedral formula for any convex polyhedron, where he stated that the number of vertices and faces together is exactly 2 more than the number of edges, which was symbolically expressed as b minus e plus f equal 2. Contributions on graph theory and topology. In 1736, Euler solved a problem known as the 7 bridges of Königsberg. The city of Königsberg, Kingdom of Prussia, now Kaliningrad, Russia, which is set on the Preyar River, and include 2 large islands which were connected to each other by 7 bridges. The question was whether it was possible to walk a route that crossed each bridge exactly once and return to the starting point. Euler's solution of the Königsberg Bridge problem is considered to be the first theorem of graph theory. In addition, his recognition that the key information was the number of bridges and the list of their endpoints, rather than their exact positions, presaged the development of topology. Lastly, here are the references used for this work. Thank you very much for listening.